I'm working on a MacBook Pro at the moment. This is an A1502, I think it is. Motherboard number is a 820 4924. And this thing has no power. It doesn't turn on. And just through process of elimination, just, starting out by just unplugging things, and also I took the board out and put it in another chassis where it worked, so I knew that it was something connected to it. I have determined that the right I/O board, which sits over here, is faulty. So these things are really cheap to buy on eBay. So, you don't really bother doing repairs on these. But I figured just for funsies, we'd just take a quick look at it and just see what had happened to it. Just in case it's something that is easily repairable, which would allow me to have this laptop fixed today instead of waiting for parts. And also just interesting just to look at failure modes of stuff. So let me just quickly put the body of the laptop to one side, and I'll show you what I found. So when I was trying to power the laptop up, it was power cycling. I had it connected. I was powering it from a DC bench power supply. And by powering something from a DC bench power supply, you can watch the power consumption and you can see little blips in the power consumption, which can be extremely helpful when diagnosing, because you can see what the laptop is trying to do, even if it's not actually achieving to do anything. So it was doing little blips. So I knew that there was probably something that was shorted, but it probably wasn't a critical short. Otherwise, it would be, not doing anything. So when I unplugged this guy, everything started working. And so if we have a look at the pinout on this guy, the pinout on this is that we have 2 grounds, and then there is a 3.3 and a 5-volt rail. And to be exact, that is PP3V3S4 and PP5VS3. So let me just figure out which one was which again. Right, bottom 2 pins are ground, and then the top, let's see. Top one is PP5V S3, and then the second one down is 3V3. So if we check the 3-volt rail, as you can see, we have lots of resistance there. But if we check the 5-volt rail, as you can see, we're shorted. So the 5-volt rail on this board is shorted. So firstly, let's take a look under the microscope and just see if we can spot what's wrong with it. I just had a look with my eyeballs and couldn't see anything, but maybe the microscope will show us something. So if we have a look at this guy under the microscope, we'll start from the top. Here's where the board interlink comes in from the logic board. This is our wireless card connector here. I've removed the wireless card just to eliminate that as a possibility. There's some support circuitry behind here, but this connector is going to be 3.3 volts, so I'm not expecting there to be anything wrong with those guys there. So let's move up a bit. There's some passives there, but again, those guys look fine to me. Let's move across. That's the SD card slot. There's nothing on this side of the board there because this is where the Wi-Fi card goes. Hence the thermal pad gunge. Then we've got the HDMI port, and there's some support circuitry here. And I think the HDMI port has 5 volts on it. I might be wrong. So this HDMI port driver could be issues with that guy, but I'm not seeing anything wrong. And this is behind a tin shield, so it looks fine to me. Next up, we've got the USB port. USB port also has a driver on it. Again, not seeing any screaming issues there. So let's flip the board over. So now we're on the other side of the USB port here. And remember, the USB port, here we go. That looks pretty jank to me. Bearing in mind that the USB port will have 5 volts on it. So this would be our prime suspect, and that guy looks pretty rough. Interesting. There wasn't any liquid damage to this laptop that I'm aware of, but maybe that guy's just spewed its guts. Either way, that, I think, is going to be our issue. We'll just have a look across the rest of it anyway. Other side of the HDMI port. Support circuitry. There's the SD card driver. And then we've got, I think, a thermal sensor up there. And back of the Wi-Fi card slot again. But yeah, no prizes for that. It's got to be that guy. Let's put the multimeter across that. And yeah, that guy's pretty shorted. It's giving me 1 ohm, but I bet if I dig through that schmutz on the back of it. There we go. Yeah, that's basically a dead short. Okay. I'm going to give that guy just a quick toothbrushing first, but I'm pretty sure that has completely perished. Ugh. Oh, yeah. We've actually got a little bit of damage to the board there. There's been a lot of heat there. Yeah, that's going to be cracked under the bottom, I think. No, that guy's coming off. No messing around. Yeah, we are no longer shorted on that 5-volt rail. Got half a meg ohm there now, 500,000 ohms. So the right I/O board isn't shown on the board view. However, 9 times out of 10, most of the stuff that is on a second daughter board is somewhere in the schematic. It's just not always obvious exactly where it is. If we have a look at the table of contents, we do have a reference called RIO connector. That's right I/O. And if we spend a lot of time looking through this entire table of contents, we'll also spot down here on page 46, external A USB 3 connector. That is going to be our external board itself. And if you're not spotting stuff because you can't see the woods for the trees, because spoilers, I didn't spot this on my first time round. The way I actually found it was look up just one of the chips on the board. So if we look up, say, the power chip for that USB, that's a TPS 2552, I think it was. Hang on a moment. Yeah, there we go. And so this takes us to TPS 2557, which is the USB port power switch that we've been working around. And as you can see, this is right side port A on external A USB 3 connector. So that's how we can find it. And on this same section here, you can see we've got the USB 3 port, and this is just all of the USB 3 stuff on the right side of the laptop. There's some other stuff of interest here as well. You can see we've got the all the TVS diodes that protect the USB port against static attacks and stuff like that. USB 3 data pins going in and out. And there's also the SMC debug MUX chip, which allows the USB port to be used as a debug port if you've got the right equipment for that. So that's kind of interesting too. However, this is the bit we're interested in. So if we have a look at this, this is the power chip that we were working in and around. If we check under the microscope, you can see here that we've got a long column of big bulk decoupling capacitors on this power rail that goes along. It goes into the chip here, and then it goes a little bit further along, and we've got 3 capacitors, a big, a medium, and a small, that are taking it down to ground. And on the schematic, there is our power rail coming in to 2 pins on the chip. And there is our small, medium, and big capacitor. Actually, I lie. These ones here, polytantalum, those are the bulk decoupling capacitors. 220 microfarads. I suddenly saw that. I was like, hold on a moment, that's not small at all. Look closelier, and you'll see that this guy isn't actually on that rail. You can see separation there. So it's actually only 2 capacitors there. And that does tally with what we're seeing on the schematic. That's our bulk decoupling. There's actually like 6 of these. There's 4 of these big boys. And then we've got a 0.1 microfarad, so 100 nano, and a 10 microfarad. So the bigger one is the one we took off the board, which is a 10 microfarad, 6.3 volt, 0402. So let's get a replacement one of those out. So let's put down a little bit more flux down there. And I think my capacitor is oversized, but it'll do. Yeah, that's an 0805 I've got there, but if we really cared about super low ESR, that would matter. But this capacitor is not really super important. It's just stability. Oh, that's way too much airflow. There we go. Don't want to blow it all away. Can you stop being sideways? There we go. Whoop. That'll do. And we'll just give that a little bit of alcohol just to clean up. Whoops, still hot. Rapid cooling. I'm sure that's good for the board. There we go. Shiny new capacitor. Done and done. Right, I'm going to fit this back into the laptop, and then this laptop will work again. Let's see if it works. Power on. So 2015, so the fan won't spin. There we go. There's a chime. And there's an Apple logo. Right. Thank you everyone for tuning in. This was a brief repair because I kind of missed out on the start of it. But I hope you guys found that interesting. I could have bought that part on eBay for £5. However, it's good practice to look at stuff before you just dismiss it and chuck it in the bin, because you never know. You might just look at it and be like, oh, I could just fix that now. And, you know, obviously sometimes the parts cost is negligible. However, it's Friday today at the time of recording, and if I'd needed to order a new Right I/O board, that would have delayed this laptop until middle of the week, Tuesday, Wednesday, that kind of time, because I'm closed on Mondays. Whereas by actually just fixing that Right I/O board, this can go out before the weekend, and that means that the customer will be a lot happier. And sometimes that can be extremely valuable for the sake of replacing a capacitor. Thank you everyone for tuning in. I'll see you next time. Bye for now.